Hello everyone. In this video, I will be explaining question 2.3 from Lab 2 Convolution for the subject EMK21803 Signal and System. Before we look at the code, let me explain what signals we are working with. For the value of alpha or A is set to positive 0.9, which satisfies the given condition where alpha is lower than 1 but higher than 0. For part A, Sn is a rectangular path equal to 1 from n equals to 0 to n equals to n minus 1 where n equal to 5. Hn is a power of n multiplied by u negative n, which means Hn only exists for n less than or equal to 0. For part B, Sn is negative 1/2 raised to the power n multiplied by the unit step un. Hn is delta function minus 3 times a shifted delta function at n equals to 1. Now we go to the MATLAB code. Okay. We start part A by setting the A equal to 0.9, n equals to 5. Then we define the index Sn from 0 to n minus 1, which gives us n 0, 1, 2, 3, 4. S is defined as a vector of ones with length n. H is computed as a raised to power nh, which gives us the values of 0.9 power of n over that range. Now because n is negative in this range, 0.9 power of n will give values greater than 1 and growing as n goes more negative. Okay. When we perform the convolution using y convolution sh, MATLAB convolution function automatically computes the linear convolution for the two vectors. We use ny negative 9 since length y negative 20. Since x starts at n0 and h starts at negative 19, the convolution output y must start as n equal to 0 plus negative 19, which is negative 19. The length of y from convolution is 5 plus 20 minus 1, which is 24. So ny goes from negative 19 to 4, give us 24 values in total. We then plot only first 20 values using ny1 20 and y1 20. Okay, for part B, we start first by defining n equal to 0 to 19. Sn is computed as negative 1/2 raised to the power of n. This gives us the decaying alternating sequence. Hn is defined as the vector 1, negative 3, which represents delta n minus 3 times delta negative n minus 1. The index for x is from 0 length of x minus 1, and the index for h is from 0 length of h minus 1. We then compute using y convolution sh. Okay. For plotting section, we put both part A and part B in one figure. Subplot 321 324 for part A Sn, 322 for part B Sn, 323 for Hn part A, 324 for Hn part B, 325 for Yn part A, 325 for 326 for Yn part B. Okay, now we run the code. For part A, Sn shows a flat rectangular path of height 1 from n equal to 0 to n equal to 4. All values are 1. Hn shows all positive values that grow in size as n move from 0 towards negative 19. Yn shows the convolution output, also all positive values plotted from n equal to negative 19 to n equal to 0. The shape reflects the accumulation of rectangular paths sliding over the growing Hn values. For part B, Sn shows a decaying alternative sequence starting from 1 at n equal to 0. Hn shows only two values, which is 1 at n equal to 0 and 1 at n equal to negative 3 at n equal to 1. Yn shows the convolution output also alternating and decaying for the first 20 values from n equal to 0. We go back to question 2.3a. Hn shows all positive values that grow in size as n move from 0 to negative 19. This is because 0.9 power of n gets larger when n is negative. The smallest value at n equal to 0, which is equal to 1, and the largest value at n equal to negative 19. That's all from me. Thank you.